Okay, so this is the second half of the program on digital compositing concepts. And we're going to talk a little bit more about some of the tools that are used to combine images together and combine sequences of images together. In the last program, we looked at a number of tools that were really all in the category of image processing tools, tools for adjusting the color of an image, things like brightness controls or gamma corrections, contrast adjustments, even hue shifts or saturation changes, or even just channel swapping tools for placing the red channel into the green channel, for instance. We also looked at spatial filters, things like blurring or sharpening, or even edge detection. And then we looked at various transformations, panning and scaling and rotating, and talked a little bit about tools like warping as well. So now we're going to go ahead and look at these image combination tools and how you can use these to really put together a composite. The whole point of compositing is to combine images together and make it look like they were shot as a single scene and not as a bunch of discrete elements that were filmed at different points in time and potentially with different cameras even. So let's look at some of these in a little more detail now. So let's look at the most simple situation where we combine a couple of images. This is analogous to what we talked about when we first started talking about color correction and how we can just do a simple thing like add a particular value to every pixel. What we're going to do instead when we've got two different image sequences coming in and being put together is we can just add these two sequences together. Effectively, every pixel in side A of the composite will be added to its equivalent pixel in side B of the composite. Here we see a result of this. We take our original first image and then our second image, call them foreground or background, and add them together. And the result that you see is sort of a double exposure, although what you also will notice is that, again, because it is an additive procedure, the pixel values all end up adding up, and you get a lot of areas that, again, go to white. Everything that, when it adds up to 1, becomes white, and you get this kind of burnt out look again. What we can do instead, when we're putting these two images together, if we don't want to get everything brightening quite a bit, is to do more of what's called a mix. A mix is simply taking both of the images and before we add them together, darkening them by a certain amount. Usually you darken them by half, since you're going to be doubling up the amount of information that's coming together. And so we take side A, darken it by 50%, side B and darken it by the same amount. And then when we add them together, we get a much better looking mix between the two images. It's something that still has everything in this reasonable range of colors, not a lot of blown out areas, and you can certainly see detail from both of the original source images. This is a real simple example we just looked at where we're dealing with a single or a pair of single still images. But of course, really, again, we're interested in doing this over sequences of images. The simple case here where we just mix between a sequence can be extended real easily to something that's known as a dissolve, where if over time we darken the first image from full brightness down to nothing, and we'll see that happening on the sequence right here, and then do the same thing to the second sequence, only in reverse, where we start off with it being black and bring it up to being full brightness. Now when we add these two sequences together, what we end up with is a dissolve. You start off looking at the first image, and it gradually dissolves away, and you see the second image. A real simple example of how these basic concepts are animated to produce new tools. That's really something that you'll see throughout the compositing process as you become familiar with your tools and the software that you're using. You'll come to realize that these are, most of the tools you're dealing with are really just built upon simpler tools, things put together with additional control for ways to animate it and things like that. So not surprisingly, you can do a number of different math operations between a couple of different image sequences, kind of like when we talked about color correction and all the different multiplies and adds and everything we could do there. So for instance, you can subtract one image sequence from another image sequence. This isn't done as often just to get an effect, since the result is usually not particularly interesting. It's usually pretty dark and not very pleasing to look at. But there is one situation where subtracting one sequence of images from another sequence is done, and that's done in the process of creating a difference mat. If you want some more detail about that, you should take a look at Stu Mashowitz's program on keying, which discusses a number of different tools for doing this kind of thing. So I just alluded to the issue of a mat and creating a mat, and we haven't really talked about that a whole lot, but we need to look at that now to get into some of the more important things that you do when you're compositing two image sequences together. So far what we've looked at gives us sort of a sense of two images dissolved together or mixed together or something like that, but the real point of compositing is you usually want to make it appear as if something is placed over something else. It obscures what it's covering. You really want to have it behave like an object does in the real world, and that it covers up the things that are behind it. And to do this, we need some additional control beyond what's contained in the original images that we're working with. We need a control image, in fact, something that's referred to as a mat. Now, the mat image, it is just another image. There's nothing particularly special about it, although it is typically something that can be done with a little bit less information. And in fact, we usually just use a single channel to represent a mat. The reason for this is there's really only one thing that the mat is controlling, and that's transparency. In a normal image, we need to have control over three things, the red, green, and blue values. But a mat just needs to control transparency, so it's usually a monochrome or a black and white or a single channel image that we're dealing with. So here's an example, an image that we have, and we want to extract this parrot from its background. We want to create a control image that lets us do that. And an image that would be able to do that would look something like this. This is the mat for the parrot. And as you can see, it follows the outlines of the parrot. It is designed to be white where there is something of interest, and to be black where there's something that where we don't want to have any information that's transferred into the next image that we're creating. If you're interested in getting some more information about how mats are created and generated and built up from the original source images, there's a couple of different programs that you should check out that are in this series. There's Stu Mashowitz's segment on keying and procedural mat extraction, and then Scott Stewart's program on rotoscoping and the tools that are used to more manually extract a mat from an image or an image sequence. So let's go ahead and use this mat image to do what we've just talked about, which is placing an image over a background so that it actually occludes the background or anything that would be behind it. So here's our original image and the mat, which we already looked at. And here's a simple background that we're going to place it over. The result of this operation will do what's called a key mix, where we're sort of mixing the two together, but it's controlled by the mat. So instead of the simple mix we talked about earlier, where we just add the two images together and get a dissolve kind of a look, this is really putting them together with the mat being taken into account, and you get something that looks like this. This is also known as an over operation typically, and let's look a little bit more about exactly what's happening when it does this over. We're placing the parrot over the background, and using this mat, the first thing we do with it is we prepare the background element for having something layered over it. So we'll go ahead, and the first thing we do is take the mat and invert it. We make the negative of the mat. So now everything that was white where the parrot exists and black where it doesn't has been inverted, and we have an image that's black in the area that we're interested in. Now we multiply this inverted mat image with the background. Here's the result that you get. As you can see, we've got something that still looks like our background image, except where the parrot's going to go. In fact, we've made sort of a big black hole that's just waiting to be filled by some sort of a foreground object. The next step's probably pretty obvious. We've got this intermediate background plate with a big hole in it, and we've got our original parrot. The only other step we need to do before we can combine them is prepare the foreground image. We take our original mat and we just simply multiply that by the foreground image, and that takes away everything that isn't parrot and leaves us just with the parrot. So we got these two images, and it should be pretty obvious that all we have to do now is add them together, and we end up with our result. We've got the parrot, and it appears as if it's been placed over the background. So this process we looked at wasn't terribly complicated, but it's probably a lot more than you'll normally have to deal with when you're compositing images together. As is the case with a variety of the other tools we've already looked at, most tools are really combinations of simpler tools. So we just looked at how you can use multiplying two images together and adding two images together with these three different images, the foreground, the background, and the mat, to produce an over. But most packages will just let you, take foreground, background, and mat and automatically deal with all those little intermediate steps. And this is real common. Like I said, that's typically the way compositing systems work, and the way they should work, which is to make your job easier and not have to deal with every single step. But it's really important to understand what is happening there for a number of different reasons. Number one, because then you can modify things to suit a specific situation you're dealing with, something that's somewhat out of the ordinary. And also so you can troubleshoot problems that you might be having. We'll talk in a little bit about different problems that can crop up when you're working with layering images together. And if you don't understand what's going on kind of behind the scenes with your tool, it's going to be much more difficult to understand where some of these artifacts are coming from if indeed you do have problems. There's a shortcut that's very commonly used in the compositing world, and in addition to the shortcuts we've already discussed of letting the computer do a number of these steps for you automatically, very often when we're combining images over a background, we know that this foreground image is going to be going over a background, and we can take that first step of taking the image and multiplying it by the mat we're going to be using to produce a new image, and sort of pre-process the images based on that. This is what's known as producing an image with an integrated mat. And so far, everything we've talked about sort of dealt with all of our images as being three-channel images. They had channels for red, green, and blue, and that made up the color of the image, and that's all you needed. But there's an additional image type that's very common, which is a four-channel image. The first three channels are the same. They still deal with color, but the fourth channel is the matte channel, and we just build it into the image so that instead of having to deal with all these files that deal with the color of the image and another group of files that deal with the transparency of the image, we can go ahead and put them into one big image, a four-channel image, and let everything work as if it were a single image instead. Let's talk some more about these four-channel images and where they are used and where they're not used, and sort of how we use them in the compositing process. When we have this four-channel image, or an image that we want to contain or keep an integrated matte channel with it, there's another decision that needs to be made. When we looked at the process of putting something over a background, one of the first things that we did was to take that foreground image and multiply it by the mat that we're going to be using. This multiplication step, when you apply it to a foreground image or apply it to the color channels of an image, is known as pre-multiplying the image by the mat. And usually, whenever we create a four-channel image, we want to go ahead and do that. Since it's the first step of the process anyway, it'll save us time later. And it also makes it really clear that we do have an image with an integrated matte channel. So given our example image of the parrot, this first step where we multiply it by its own matte channel, the RGB channels look like this, and of course the matte channel still looks like this. This is considered a four-channel pre-multiplied image, and that's typically the way we work with four-channel images. We go ahead and do the pre-multiplication. Unfortunately, it's not the way it always happens, and there's no guarantee that in a 4-channel image it has been pre-multiplied by the mat. And so this is something that's constantly dealt with as you're working with your compositing tools. And you really need to be aware of what kind of 4-channel image you're being given, whether it is pre-multiplied or not. If we look again at the image of the parrot with the mat, but let's go ahead and look at it without the pre-multiplication having been applied. So the RGB channels still look just like the original image, and we have the mat channel in here like that. This would be a non-pre-multiplied 4-channel image. So there's a big distinction there, and we'll look at why this distinction is so important and where the problems can crop up if you have using one and you're expecting the other. By the way, when you're working with CG imagery that's produced out of a 3D animation package, for instance, it almost always will produce a 4-channel pre-multiplied image. It will deal with that step of multiplying the color channels by the mat channels. And in fact, this is something that's done in the renderer of the 3D package, and properly sets up the transparency information in the color channels to reflect the transparency that is contained in the mat channel of the image. So usually when you're combining CG elements, you know that you're getting something that's pre-multiplied. Conceivably, this isn't the case if somebody's done something sort of strange, but it is pretty much of a convention. That's not necessarily so much of a convention, however, with working with live action footage that's combined with a mat. Incidentally, something to be aware of, and it's a warning I've probably already said at least once, and I'll probably say at least one more time. Different packages will deal with the concept of a mat image differently. Some packages sort of make the assumption that it's an integrated mat, and then anything that's not integrated is a special case and might be referred to as a track mat, or there's different terminology for it. Other packages will assume that none of the images have an integrated mat, none of the images are pre-multiplied, and that everything will be done explicitly, combining an external mat. Let's go ahead and look at some of the problems that can come up if you feed a system that's assuming one type of an image, something else that is a different type of pre-multiplied or non-pre-multiplied image. Let's look at a new sequence of images, or a new couple of example images, to discuss this issue of pre-multiplied versus non-pre-multiplied in a little more detail. We've got our foreground image here, which just shows a dog in front of a neutral kind of a wall. Let's look at the mat we're going to be using for the dog. It's a much more soft-edged mat, and this was done intentionally because it's going to really accentuate some of the problems that can show up. So if we take our dog, whose name is Mandy, by the way, and multiply by the mat, we have this pre-multiplied image here. It's the dog with everything else kind of dropped out of the scene. It's a soft-edged mat, so you can see a lot of feathering along the edges. But fortunately, this is going to work okay because we're going to be placing it over this background here, which was shot from the same camera location and has the same background behind the scene. So whenever we layer this in, the feathered edge isn't really going to matter, and in fact we want to get a nice blend between this foreground element and the background that we're placing it over. So here's what happens with this situation. We take the foreground element, pre-multiply it by its mat channel, and then place it over the background. And this is the result we get. Everything looks fine. It appears as if the dog was in the scene with the cat. However, if we do something like don't pre-multiply the foreground before we place it over the background, we get a result that looks like this. As you can see, everything is blown out around the edges, and we've got a huge problem with our composite. So that's the first situation where you can have a problem. If you try to take a system that expects a pre-multiplied image and feed it an image that's not pre-multiplied. An additional problem can occur in the other direction. If you've got a system that is planning on doing the pre-multiplication for you automatically, i.e. if you have a system that expects to get an image that's not pre-multiplied and then a separate mat, and it will do the pre-multiplication before it layers it over the background. If you have a situation like that and then you go ahead and give the system an image that's already pre-multiplied, what's going to happen is that it's going to attempt to pre-multiply the image again based on the mat channel. Here's the result we get with that situation. You'll notice that there's a very obvious problem with this one. There's a very obvious dark line or a dark halo that's kind of floating around the dog. This is probably not what we want either, and like I said, it's a direct result of the system thinking that it's going to have to do something that's already been done to the image in the first place. So you can get either one of these situations can crop up all the time. The only way to avoid it is to know, number one, what kind of an image are you dealing with? Has it been pre-multiplied or not? And then number two, know what your software is expecting to do with it, whether the operator you're working with or the software in general is expecting pre-multiplied images or is expecting non-pre-multiplied images. Usually it's pretty easy to figure out what kind of an image your system is expecting or your particular operator is expecting in terms of multiplied or pre-multiplied. The problems will be pretty obvious. But there's a much more subtle problem that can occur, and it has to do with an image that is pre-multiplied but maybe not pre-multiplied in quite the right fashion, or more specifically, something that's been pre-multiplied and then has been modified after the fact. So normally when I pre-multiply an image and then apply it over a background, everything should look fine and the edges should be good. But it's important to understand that this pre-multiplication has produced an image that has a specific relationship between the RGB channels and the color channels. Here's our foreground image again, pre-multiplied by its matte channel. As you can see, of course, the edges feather off towards black as the matte itself was going towards black. The process of doing the pre-multiplication produced an image that was going to be acceptable whenever we place it over a background. However, if something happens to this image before we place it over the background, if some additional processing is done on it, this can cause problems in the composite. The reason for this is that there is a relationship that's been established between the color channels and the matte channel. And if you do a color correction on it, it can compromise that relationship. If I apply a noticeable brightness to the image, or even a very dramatic color shift in some direction, the transparency information, the transparent edges around the outside of the dog are going to change, yet the matte channel isn't going to change. All these color corrections we work with typically do not affect the matte channel. So let's take a look and see what happens if I go ahead and play with some of the color information in the image and then place it over the background. You can see that the edges are starting to have problems. This is fairly noticeable in what we're doing here, but it can be much more subtle and a lot harder to diagnose as well. There is, fortunately, a couple of things we can do to deal with this. If you're dealing with live action images that you're going to be combining with the matte, the most important thing you can do is make sure you do the color corrections before you do the pre-multiplication, before you combine it with the matte. This will solve all of the problems because as long as the last step is the multiply operation, then the proper image will be produced. But what about a situation where you don't necessarily have a full image? The most likely case is if you've got a CG element. Somebody's rendered something, and the only way you can get it is as a pre-multiplied image with the matte integrated and the foreground already pre-multiplied by this background. What can you do then to help deal with these color problems? Well, there's a little trick that you can come up with that usually takes care of that, and it is essentially trying to create an image that hasn't been pre-multiplied. We don't have all the information there, but let's take a look at what happens whenever we do this on the dog image that's already been pre-multiplied. We've got a pre-multiplied image here. Now what we want to do is actually divide by the matte that's contained in there. I'll show you what that looks like right here. So you can see we didn't completely recreate the original image. Anywhere the matte was completely black, there's no way we could recover image information. But what did happen is all along the edges, anywhere there was partial matte coverage or partial transparency, the dividing by its own matte has kind of restored it to what the original image looked like. It's boosted all of this transparent imagery back up to full brightness. Now that we've got this intermediate image, we can almost treat it like a non-pre-multiplied image. In fact, we can treat it like a non-pre-multiplied image. We can do whatever we want with it in terms of color corrections, brightness adjustments, and everything like that. So if we go ahead and dial in a particular brightness adjustment, and then go ahead and multiply again by the matte, which we still got the original matte that's contained with the image, we produce a new pre-multiplied image, but it's not going to have any of the problems that would be there had we tried to color correct the original pre-multiplied image. So there's a variety of different tools that you can use to combine two image sequences together, far more than we have time to cover in this program. But the important thing is to go through your compositing package and kind of know what's available and what it can do and what it can't do, and what you might need to use a combination of tools to put together. But I mean, there's different tools for placing an image under another image instead of over an image, like we talked about, or tools such as the screen function, which is a different way of combining imagery together. You can even use tools to do some kind of selective warping, like a displacement tool, where we can take our first image, and here's an example of it, take an initial image and use it to displace the second image. So you can see that the result is kind of a distorted image that has some of the characteristics of both. One of the other things that you want to be doing when you're combining images together is using some of the image processing tools that we talked about in the last segment, and use those to help you do the combination. And the most important thing that you're probably going to be dealing with when you're putting images together is what happens along the edges. Whether your foreground element is something that was shot on blue screen and then a matte extracted for it, or even if it was a computer-generated image that comes with its own matte already built in. A lot of times the thing that takes the most attention to detail is how those edges are working into the scene. How do the edges of the foreground object fit into that background scene? The edges of your matte may be produce an edge that's too hard or too soft, and you'll need to do some modification to deal with that. Let's look again at our foreground image and see what we can do to treat the edges a little bit differently. Here's the image itself, and let's blur the matte a little bit before we place it over the background. You can see it gives us a nice soft edge in there, which may or may not be appropriate. You can certainly go too far, as we see here, and get something that's very unrealistic looking, but sometimes just a slight bit of blurring along the edges can help integrate something into the scene much better. And this ideally is done before the matte multiplication happens. And in fact, if you do it on a pre-multiplied image without taking into account the fact that it is pre-multiplied, you can sometimes introduce problems instead. If you go ahead and treat the matte and then do the multiply, you should be fine. There's a number of other tools, some of which we discussed in the last segment, that can be used to determine where the edge of an image is, or where the matte's edge is, and you can just do treatment specifically along these lines. So here we have an edge detection of the matte for the parrot, and we could use this little matte to do any kind of specific treatment that we wanted to do on our foreground or even on the composite image. So we can take this matte and use it to do a specific color correction, for instance, within the area of the matte. One other quick thing that you may want to do sometimes if your matte just doesn't quite fit the image is that you can use some tools to expand or contract the matte a little bit. Sometimes a contrast can do this if you've already got soft edges on your matte, or there's some tools that are known as things like dilate and erode that will let you grow or shrink the matte a little bit before it's used to apply this to the background. Again, only use this carefully and use it so that it makes sense, but sometimes if you've got a problem with a little bit of fringe around the edge of an element, you can kind of shrink the matte in a little bit and do that. Now let's talk a little bit about something I alluded to just a second ago, which was using a matte image and not really using it to deal with a compositing issue in terms of how you layer something over something else, but using the matte to control some other operation. In the last segment of this program, we looked at a variety of different tools for color correcting an image and even blurring an image or sharpening an image. But we don't necessarily need to apply those things to the image as a whole. Instead, we can use a matte to limit where we're applying these operations. So in a very simple case, let's look at a matte such as this, which is just an arbitrary shape, and let's use it to control how we're applying a color correction to our image. So we have our matte, and if I was to apply the color correction to the entire image, it would look like this. But if I limit it using the matte, instead the color correction looks like this. Now this may not be the most real-world case, since you're probably not going to want to have this big ugly shape color corrected in the middle of your image, but you can see that there may be times where you've isolated an element. You don't necessarily need to extract it from the background, you just want to color correct a specific element. And again, other programs will talk about rotoscoping tools for defining mattes like this. But once you have the mats, you can use them to do any number of different processing operations. Instead of a color correction in a specific area, you might want to do a blurring in a particular area, or even blur a piece of the background to push it farther out of focus or something like that. So be aware that the mat is a useful tool even if you're not trying to combine images, just if you're trying to manipulate images. Let's look at another tool that's really a combination of tools we've already looked at. This is something that's known as morphing, and it's a way to kind of transition from one object to another object, but in a more subtle fashion than simply a dissolve. We'll look at a very simple and obvious example of it, and then obviously you can extrapolate to how it can be done in a much more subtle fashion. So given our two elements, here's the first element that we want to look at, and the second element, and what we want to do is transition between the two. We already talked about a dissolve, like I said, and here's just what a simple dissolve would look like between these. But it really doesn't give the sense that one object is changing to the other so much as you're just dissolving between the two. Morphing will take some of the warping tools that we looked at in the last program and use them to kind of help the transition and make it feel much more natural and much less noticeable. The way this works is that we take the first object that we're working with and we will warp it so that it starts to take on the shape of the second object. And an example of this is shown in this quick little sequence here. So you can see it is distorting so that it starts to take on the shape of the second object. At the same time, we're going to take the second image and distort it or warp it so that it starts to take on the shape of the first image. Now you can probably see where we're going with that. What we want to do now is take the second sequence and reverse it so that it starts off having the shape of the first object and then it comes back to its own shape eventually. The last step then is very simple. We go ahead and we do the dissolve like we were talking about originally, but instead we dissolve with these new sequences we've created. So as the dissolve happens here, we've also got the warps happening on both of the images, and what you get is a much more smooth transition between the two. It appears as if the first object is really changing into the second. There's a lot of additional subtlety that could be introduced to make this an even more interesting morph between the two subjects. Instead of doing a dissolve that's just simple from A to B and linearly, we could dissolve different segments in at different points in time so that the eyes might dissolve first or something like that. And we can also do the same thing with the way the warps happen, that you may want the outside shape to warp initially and then some of the other warping to happen at different points in time. That's really the key to doing a good morph, is to looking at very subtle details and trying to make it appear as if it isn't an automated or computer-generated process, but that it is a very organic change that's happening between the two objects. Morphing is something that you've probably seen a lot of for a while there, especially. It seemed like just about every television commercial had some kind of a morph going on inside of it. But morphing can also be used in a lot of situations for much more subtle effects. A good example is something I worked on in one of the films I worked on, where an actor was supposed to be knocked over by a lion, and they didn't really want to have the real actor be hit by a lion. So what instead was done is the actor stood in the scene and was photographed, and then without moving the camera, a stunt double was replaced, and at the same time the lion tackled the stunt double. Then, to make it appear as if the lion was actually hitting the actor, a very quick and subtle morph was done between the two. The morph was done right at the period in time whenever the actor was being hit by the lion, so that it wasn't noticeable, especially with all the other action going on. The morph was occurring, but you got the action of the stunt double being hit, and it appeared to the audience as if the actor itself had been tackled by this lion. So let's talk about one more topic in tools for combining images together, and it's something that's known as Z-depth compositing. Z-depth compositing is a tool that's used almost exclusively with synthetic or CG images. And the reason for that is because we need to have the computer generate some additional information that we can use. This information is known as a depth pass or a z-depth pass. And what it is yet another image, similar in concept, I guess, to a matte image, but this image, instead of defining the transparency of the image, is going to define the distance from the camera for every pixel in the image. So let's take a look at this image here, which is just a bunch of balls kind of floating in space. And the z-depth image for that looks something like this. You can see that it represents the distance that the ball is from the camera in terms of the brightness in the z-depth image. Balls that are farther away are given a different brightness than those that are near to camera. This tool then, having this image, lets us use a tool for combining it with other images that can kind of automate the process of determining what's in front of something else. Here's a second image that contains a bunch of different shapes, and here's the z-depth image for that particular image. So given the fact that we know the depth relationships between all of these different objects in the two scenes, and we have that depth relationship defined in the z-depth images, the computer can then automate this process of putting things behind other things. Here's an example of an image that was composited together using this z-depth information. As you see, there's not all the foreground objects over the background objects, but rather things are placed based on their depth or their distance from camera. Again, this is something that's almost exclusively used just with computer-generated imagery because we do need the z-depth information, but it can sometimes be used with live action if somebody takes the trouble to go in and explicitly create a z-depth image by hand, painting different depth passes so that you can use this z-depth tool for automating the compositing process. Let's take a look at a scene where z-depth compositing can't be used, or at least can't be used very effectively. Here we've got a glass sphere in a scene sitting in front of a checkerboard background, and here's the z-depth image for this particular scene. So you can see that the sphere is closer to camera than the wall in the background, and this is a perfectly normal z-depth image. Now let's take a look at a second image that we would like to put into that scene. Just another shape and floating on a black background, and here's the z-depth image for that. If we just use the z-depth tool to combine the two images, it would be able to look at this new object and say its distance is farther away from the camera than the crystal sphere is, but it's still closer to the camera than the back wall, the checkerboard wall, and it should be able to go into the scene. And in fact, if we use the z-depth compositing software to put this into the scene, here's the result we get. Well, as you can see, that's probably not what you want. The problem is the z-depth software looked at the crystal sphere but had no sense that it had any kind of transparent or even refractive properties. All it knew is that it's closer to the camera than the new object, and therefore it should cover up the new object. That's probably not what we wanted. If we look at the same scene and just render it out as a single scene within the 3D package where it deals with transparency properly, here's the result that we get. And you can see that the object can be viewed through the glass sphere, although distorted as you would expect if you're working with a real glass ball. So anytime you have transparency in an image, z-depth compositing is going to be less useful, or in some cases completely useless. It goes even deeper than that, however, in that even though you may not have an obvious transparent object like a glass sphere, the transparency or the edges of an object that are in a scene can very often be slightly transparent as well. This is most commonly the problem that you see if you're doing z-depth compositing. Certain slight artifacts can show up around edges, and there's no magic solution for how to deal with these. They kind of need to be dealt with on a case-by-case basis. But anytime you're doing a z-depth composite, the important thing is to see what's happening around edges or any area of partial transparency, and you may have to treat that separately in a special fashion. So we've covered a number of different tools that can be used to manipulate images and combine images to make a new scene. The important thing to remember is that everything we did talk about were just tools, but they're not really the important part of it. The important part of building a composite is producing something that looks visually correct. You'll need the tools to do this sort of thing, but the real difficulty comes in making it look right. What we didn't really talk about so much in this segment was why you tend to do this, or why you would want to use these different tools. And really, more importantly, what are the things that you're looking for when you're integrating an element into the scene. These topics were covered in the segment on visual effects cues, a different program in this series. And in general, you should keep an eye on things like lighting and what shadows are doing, what the colors in the scene are, what kind of distance cues you're getting for how far away certain objects are in the scene or from the camera. All of these things are what the artist uses to combine these images and to put together a scene so that it really appears like it's an integrated scene, that it was shot with just a single camera at a single point in time, and that it's not a combination of a bunch of different elements that were placed together in post-production. If you're interested in more information about a lot of these different topics, I would encourage you to check out other programs in this series, and information on that can be found on our website. I've also written a book on digital compositing that goes into much greater detail about a variety of things that are related to digital compositing, and information on how you can get that is also at the end of this. Thanks.